be looking at equations with the variable on both sides. Alright, first I want to review what an inverse operation is. So inverse operation is just the opposite. So if we're adding, how do you undo it? The inverse is subtracting, subtracting is adding, multiplying is dividing, dividing is multiplying. It's just the opposite. Alright, so what is your goal? Your goal when solving equations, our main goal is always to isolate your variable. That means get the variable on one side and a number on the other side. Alright? Your variable can be x or y. It doesn't always have to be x. Alright, remember, humans, aliens, and dogs. For instance, your humans are your 1s, your aliens are your x's, and your y's are your dogs. Okay? You can't combine humans and aliens. You have to keep them all separate. So, how do we model an equation with a variable on the both sides? How do we model this? Well, it says use the algebra tiles below to model and solve x plus 5 is equal to 3x minus 1. Alright, well our first one is, here's our mat, we set it up, so we have 1x, sorry I forgot to put this on here. The long ones are your x's and the short little ones are your 1's. Alright, so the positive and negative, obviously that means pluses, or the plus and the minuses obviously mean positive and negatives. So we have 1x on one side, then we have 5 1's on the other, is equal to 3x's minus 1. So it says we modeled x plus 5 on the left side of the mat and 3x minus 1 on the right side. Remember that 3x minus 1 is the same thing as 3x plus a negative 1. So you could look at these as plus signs in between here. Is all that's saying. Alright, well we know we have to get the humans on one side and the aliens on the other, or we have to isolate our variable x. So let's see what they did. Okay, they removed one x tile from both sides. So they saw that there's 1 over here and there's 3 over here, so it's easier just to take one alien away over here. And so if you take one alien away on one side, you have to take one alien away on the other. This represents subtracting x from both sides of the equation. So all we did was we took minus x and we minus x over here. Because what you do to one side, you have to do the other. Now that we have all of our x's or all of our aliens on one side, we have this one human left. This human can't be with the aliens. Remember, the human has to be over here. So how do we get the human to be over here? Well, remember, we want to take it away, but I can't take it away because I don't have a negative to take away over here, right? So how do I do that? Well, if you just had a minus 1, how would you get rid of a negative 1? You would add 1, right? So that's all we did. We added 1 on this side, and if you add 1 on this side, you have to add 1 on this side. So here's the one that they added, and here's the one that they added. So it says, place a plus 1 tile on both sides. This represents adding 1 to both sides of the equation. This makes a what? Remember we talked about it makes a 0 pair. 0 pairs, they cancel out. Right? So now you're left with all your aliens or your x's on one side, and you're left with all your humans on the other. Well, we have 2 x's, but the goal is to figure out how much 1 x is worth. So separate each side into 2 equal groups. 1 x tile is equivalent to 3 plus 1 tiles, because 3 will go to this x, and 3 will go to this x. So x is equal to 3. Okay? So how do we check our answer? We substitute our solved value into our original equation. So our original equation was x plus 5 is equal to 3x minus 1. Alright, well I have x is equal to 3. So I know wherever I see an x, I can put a 3. 3 plus 5 is 8. 3 times 3 is 9. 8, and then 9 minus 1 is 8. Is 8 equal to 8? Yes, it is. So we know our answer is correct. Alright. Now we're going to go to the back. And we're going to look at solving an equation with the variable on both sides. So now not with the modeling, just the straight up solving. Alright, so Andy's rental car charges an initial fee. We know that word initial is important. Initial fee of $20. plus, so I'm going to highlight that instead, plus an additional $30 per day. Okay, Buddy's rental car charges an initial fee of $36 and plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? Okay, so when we're doing variables on both sides, this is a good way to model real life situations. So step 1 says write an expression representing the total cost of renting a car from Andy's rental car. Well, Andy's was the first one, so I know an initial fee. When I hear initial fee, I know that's kind of like my y-intercept. So it's always a plus 20 because no matter what, you're going to have to add 20. And then I see this $30 per day. Per day, I know that's a unit rate. And when we have a unit rate, that means it's my slope. So I have 30x. Alright, so I did all that. So now Buddy's, I see an initial fee, and I know initial is my y-intercept. Plus an additional $28 per day. $28 per day is going to be 28x, right? Because it's our slope. So we did both of those. So it says step 3 says write an equation that can be solved to find the number of days for which the total cost charged by the companies would be the same. Hint, set your two equations equal to one another. So I gave you guys a hint. Alright, so the first thing you need to look for is can you combine any like terms on each side? I got aliens and I got humans and I got aliens and humans. So they're pretty much separated, but now I want to separate them onto either side of the equal sign. So I want all my aliens on one side, or doesn't matter what side, but whatever side my aliens are on, my humans have to be on the other. Okay? So, let's see. Rewrite it down here. 30x plus 20 is equal to 28x plus 36. Now let's move our aliens first, our x's. Where do we want to move our x's? Do you want to move 30 to this side, or do you want to move 28 to this side? I personally would move 28 because if I know this is a positive 28x, and this is going to be a bigger number minus a positive number is going to be easier than doing 28 minus 30. So how do we get rid of positive 28x? You subtract 28x. That gives you 0. So we subtract 28x on this side. You have 2x. This cancels out. Rewrite your equation. Now, aliens have staked this side. The x's are on this side. Now I need to get my humans away from the aliens. They can't be together. So, how do we get rid of a positive 20? Good, you subtract 20. So we subtract 20. This cancels out. We have 2x is equal to 36 minus 20 is 16. 2x is equal to 16. Now, my goal is to figure out how many days. Well, how many days? I don't know yet because this is talking about 2, however many. So how do I solve for just x? Divide by 2, because this is a multiplication problem. So to undo multiplication, you divide. If you divide this side by 2, you have to divide this side by 2. This cancels out. We have x is equal to 8 days. Now we have to check. Alright, well you check by plugging it into your equation. Okay. So 30 times 8 is 240 plus 20 is equal to 28 times 8 is 224 plus 36. 240 plus 20 is 260 is equal to 260, so it checks off. So after 8 days, the car companies will be the same amount. So that was our question was, what number of days is the total charge by the companies the same? After 8 days, the companies will charge the same amount. The last thing we need to look at is how to write a real world situation from an equation. So kind of going reverse. If you're given an equation, can you make up a real world situation to fit it? So, an equation with a variable on both sides can be used to represent real-world situations. That's what we just talked about. Like above. Write a real-world situation that could be modeled by the equation 150 plus 25x is equal to 55x. Well, step 1 is to look at the left side. The left side of the equation, which is this, the left side of the equation could represent the total cost for doing a job where the initial fee plus an hourly charge. Your initial fee would be 150. IF stands for initial fee. Hourly charge would be the 25, because remember unit rate, hourly. Alright, so step 2 says the right side of the equation consists of a variable term. So it could represent the cost of doing the same job based on just an hourly charge only. So they don't have initial fee, so no initial fee. So this is where your imagination gets to come into play. Alright, I was kind of boring and I just did something easy, but my example, or step 3 would be the equation 150 plus 25x is equal to 55x could be represented by this situation. Now, I will give you a heads up. For Ms. Hitchcock's class, at least, your warm-up tomorrow is going to be me giving you an equation and thinking of a fun word problem, and we're going to share. So you might want to really pay attention to how I did this. Alright, I said a handyman charges $150 plus $25 per hour for house painting. So to paint the house, they charge an initial $150 plus $25. A painter charges $55 an hour. So I've covered this side first, and then this is the painter. So this was the handyman side, and this was the painter's. How many hours would a handyman have to work before their fees are the same? So how many hours would they have to work before they charge the same amount? Alright, that's it. And I hope you have a great night. We'll see y'all tomorrow. Bye.